Hello. Okay, so I'm taking a break from the OTV, over terrain vehicle series, and I am exploring a new concept because that is what I love most. And this time I'm moving away from the idea of the compact, easy to store vehicle for one person in favor for a more dreamlike vehicle, which is like a flying picnic or something like that. So it's supposed to be like a gentle hovering vehicle with a like half spheric bubble in the middle, perhaps 2 meters in diameter, which is the picnic surface. And there's 3 giant wings surrounding that half sphere, and it's a super slow sort of rotary wing thing, and this is a scale version of that. And the reason I built it this large is that I want to explore the flight controllers and the craft's characteristics with a 60 RPM flight speed of the propeller, and to be able to reach such a low speed, 1 revolution per second, I need to have a very light vehicle. It needs to be light in comparison to its size, and I want to use common materials. So this is the size I ended up with. It's a 5 meter diameter wing constructed of aluminum tube and packing tape, and like common material like that. And I calculated that its takeoff weight, if I can keep it to around 12 kilos, I will be able to take off with at 60 RPM, 1 revolution per second. I'm just feeling for the overall rigidity. This is the first time I assemble it, and it's not at all it's sort of like a helicopter, but it's not. It doesn't have any of the helicopter properties, so it doesn't have the centrifugal force to keep the wings stiff, so I had to brace them, or to build them, of course, with higher grade materials, but I'm not interested in investing that kind of money, so I'm going for aluminum and steel wire bracing. So it's sort of a tip jet system. Well, there are propellers, of course, so they're high pitch to compensate for the operational speed at the tips, and it's a high power and high speed servo controlling these control surfaces. And amazingly enough, you can go from a thrust value of 2 and your standard value could be like 5, and the maximum value would be like 7 or 8, depending on how you deflect the control surface. So it has a very large impact on the lift, that even though it's quite a small surface, but it's far out on the wing, so it has a decent airspeed. Okay, so almost everything is spinning except for the center portion and the shaft itself. So I had that clip there just to help me keep orientation. Here's the flight controller, so it will be stationary, it will not rotate. And that means that I have the power for the flight controller, but also for the yaw motor there. So that motor is connected to the flight controller and keeps the flight controller stable in yaw. And I got 1 battery pack, or 1 double pack for each wing, with a connector there, so that I can disassemble the craft. There you can see the wires to the motors going in just behind the leading edge there. And here's the commutation. So it's set up like a hexacopter actually. So it has 6, sectors, and you can see later on how the servo reacts when it goes from one sector to another sector. So everything is ball bearing here. So it's the wire seat there, of course, but also the landing gear is set on ball bearings in relationship to the main shaft there. It's packing tape, and I've shrunk it with a heat gun, so it works surprisingly well to use packing tape and heat gun. And here you can see when I'm running it really slow, the commutation of the flight controller to servo. So there are distinct steps there that occurs. And I guesstimated that 1 revolution per second, that is 6 sectors that the servo has to commutate per revolution. There is about the maximum that the servo can handle, so that it has the time to do adjustments, and those adjustments has to have a little bit of time to have an impact on the flight path or the attitude of the craft. Here you can see the yaw motor there, keeping the flight controller board there fixed in the yaw. So and it's a cheap screwdriver motor there with a gearbox connected to a large 3D printed sprocket there on the propeller. And here I shut it off so it starts to follow the propeller. Okay. This is not the very first flight. The first flight that actually hooked up the I set the flight controller inverted in relationship to yaw, so it didn't work at all. But this is the first time I have the system properly set up. And when this baby hits 60 RPM, it should take off. So that's exciting. The primary objective for this first flights are, of course, to just establish that the craft has the structural integrity to, do what it's doing, but also to find out how many degrees offset I have to set the commutation board. So how much does it lag? How long time beforehand does the servo need to have its input to not have like toilet bowl movement of the craft, or just veering off when you're like pushing the stick forward, it might go to the left or something. And it turns out so far I think it's good to be somewhere like 10 or 15 degrees offset, like the servo gets what is it? It's 1/36th of a second time to start reacting and doing the control surface movement. That seems to work. So the machine flies, but it's like the flight controller can keep it level, but I don't feel at all connected via the sticks of the controller. So I feel that I'm more of a spectator than a pilot. So that's very unsatisfactory, but it's so cool that it actually flies. And for all of you out there that are like me, like very interested in the details and every aspect of this, the flight efficiency of this setup right now is around 12 grams per watt input in the system. So it's not super impressive, but it's still an interesting gearing of the propulsion propellers there. Yeah, isn't that beautiful? It's a nice slow airstream coming off the big propeller, and of course going down is more difficult than going up, since the wings tends to stall when it's going down through the air. So it's funny that it's easy to go up and hard to go down in this aircraft. Okay, this was just the first clip here. I will get back in this subject if it turns out to be like a favorable concept. See you.